Hello, this is Mrs. Ward, and I am going to go over section 2.4 in your textbook, the chain rule. So what we're going to do with the chain rule is we're going to take the derivative of a composite function. We're going to find the derivative using the general power rule, and then we're going to simplify derivative using algebra, and then find the derivative of trig functions using the chain rule. So let's get started. Maybe. Okay, so the chain rule basically says that if you're taking a composite function, and remember from Algebra 1, Algebra 2, the composite function is f of g of x. And what you're going to do is you're going to take the derivative of one function inside of another function. So here's basically what they want you to do is you're going to have f of g of x. So you're going to take the derivative of the outermost function first, leave the innermost function alone, and then take the derivative of the innermost function. And you may have to do that more than once depending on how many functions are within a function. And right now you probably have no idea what I'm talking about, so let's start with a baby one. So for the first one, I have the square root of 4x squared minus 5. So what I've done is the innermost function that I have here is 4x squared minus 5. So I've written that as u. And then the outermost function, which I'm calling y, is taking the square root of that, of what's inside. So you're basically doing f of g of x. So what I'm going to do is I'm going to first take the derivative of the outermost function. So I'm going to rewrite this first. So I'm going to think of this as 4x squared minus 5, and I'm going to think of it as being raised to the 1/2 power. And that's f of x. I haven't changed it at all. So I'm going to say that u is equal to this 4x squared. So I'm going to say that f of x I'm going to think of as u to the 1/2 power. So if I were to ask you to take the derivative of anything to the 1/2 power, you would say that is no problem whatsoever. You would just take the power, which is 1/2, times u, and then you reduce the power by 1, so 1/2 minus 1, you'd have negative 1/2. That's the first part, and that's right. And that's the part right here. That's me taking the derivative of f of g of x, and here I've just put a u in here. So now what I'm going to do is I'm going to look, and I'm going to multiply it, and I'm going to look at what u is, and I'm going to find the derivative of u in terms of x, and that's what this du dx stands for. So now I'm going to take the derivative of this u. So taking the derivative of this, 2 times 4 is 8x, reduce that by 1, so it's just going to be 8x. Then I'm going to put this all back together. So I am going to have, if I multiply 1/2 times 8, that would be 4x over u to the 1/2 power. And I'm getting rid of the negative exponent by putting that u in the denominator. Then the very last thing you have to do is you're going to take this u, what u is equal to, and you're going to put it back into, kind of like chunking. Remember when we did chunking? Exact same idea. So now when I take the derivative of f of x, I'm going to say that's equal to 4x over the square root, because it's raised to 1/2 power, of 4x squared minus 5. And that is the derivative using the chain rule. So let's do another one. So this time I have a trig function. I want to find the derivative of cosine 3x. So the outermost function is taking the cosine of a function, so that's going to be my y. The innermost function is 3 times a number, so that will be my u. So if I thought of this as f of x is equal to cosine of u, and I asked you to take the derivative of that, you would do the derivative of cosine is negative sine, and then u, and that u doesn't change. We've never changed that before. So now what's going to happen to find the derivative of this whole thing, I'm going to take that, so negative sine u, and I'm going to multiply it by the derivative of this inside function, or 3x, and the derivative of 3x is just going to be 3. So to write it and unchunk, or put the u back in, the 3x back in for the u, I'm going to have negative 3 times the sine of 3x, and that's my derivative. Now, will you write all these steps every time? Probably not, but that's what you're doing. So the next one, I have several things going on to this x. If I think of this x, I have several things going on. I have it being multiplied by 2 and adding 3. That's one thing. I have me taking the cosine of it. So that would be a second thing. And the last thing would be taking the square of the whole thing. So if I rewrote this, I could rewrite this as cosine of 2x plus 3. And since that cosine, that squared sign's there, this whole thing is being raised to the second power. So when I use the chain rule, I start from the outermost function. So in this case, my outermost function is raising something to the second power, and I take the derivative of that. So the derivative of raising something to the second power would be to take the 2 and bring it out in front, and then decrease it by 1. This does not change. So this will still stay cosine of 2x plus 3, and reduce the power by 1, so that'll be 1. And I think I need another parenthesis. Then I'm going to switch colors here because the next function I have is cosine. So to take the derivative of the cosine would be negative sine. So I'm going to multiply this by negative sine and then leave that parenthesis alone, 2x plus 3. And the last thing I have going on is I have this x in here being multiplied by 2 and adding 3. So the derivative of this 2x plus 3 is just simply 2. So I'm going to multiply this by 2. So the derivative of this whole function is kind of like, it's kind of like links in a chain. This would be one link, this would be another link, and this would be another link. I have to put all those links together to form the chain that makes this the derivative. So when I multiply all this, I'm going to take 2 times 2 and that negative sign. So this will be negative 4. And then I'm going to have cosine 2x plus 3 times the sine of 2x plus 3. And I can't write it any simpler than that. That's all I can do with it. So I am done. So the next one actually explains a little bit more about the general power rule. The general power rule says that if you have something raised to a power, like I have this function raised to the 4th power, I'm going to take care of that being raised to the 4th power first, and then I'm going to take the derivative of what's inside. So if something being raised to the 4th power, the derivative would be 4 times that, and then decrease the power by 1, so this would be 3. Whatever's in that parentheses stays exactly the same. It does not change the first go-around. So that doesn't change at all. Now I'm going to multiply it by the derivative of what's inside here. So the derivative of 2x would be 2. The derivative of 7x squared would be plus 14x. And then I could rewrite that. I'm going to factor out a 2 here, multiplied by that 4. So that would be 8 times 1 plus 7x, because I factored out 2 there. And then 2x plus 7x squared, that whole thing raised to the 3rd power. And that would be my derivative. Does it matter the order that you might put these in? Not really. Does it matter whether or not you factor out that 2? I'm going to say not really, but it's a good habit to get into, to factor out your greatest common factor. So I always do it. And if I were there and we were there, I'd probably be taking off half a point if you didn't do it. So just, that sounds like a plan to me. All right, moving on. You're taking a derivative involving a radical. So it's the exact same thing. I'm going to rewrite this so that I'm taking the cube root of something squared. So I'm going to rewrite this just like we learned how to do in the last section as x squared minus 2. And combining that, this is going to be raised to the 2/3 power. Then to take a derivative of something raised to a power, I'm going to multiply by that power, which would be 2/3. Leave what's ever in here alone, so that x squared minus 2 is not touched the first go around. Take 2/3 and subtract 1, so this will be negative 1/3 power. Then I multiply, and this is the extra step now. I multiply by the derivative of what's inside here. So the derivative of x squared will be 2x, and then that's because the derivative of 2 is 0. I'm going to multiply 2x times this 2/3. I'm going to have formed numerators and denominators while I'm at it. So the 4x will be in the numerator, the 3 will be in the denominator, and since this is raised to negative power, I'm going to bring that down to the denominator because I cannot have a negative exponent. And that's going to be my final derivative, just 4x over the 3 times the cubed root of x squared minus 2. Now I'm going to read the rest of the question. It says, find all the points on the graph for which the derivative is equal to 0. So that's this first part here. So I'm going to set this equal to 0. Remember, when you have a rational function, the only time this rational function b equals 0 is when your numerator is equal to 0. So 4x is equal to 0, which means x is equal to 0. And it wants the points, so now I have to go find the y value. So my x value is 0. I'm going to put 0 back into my original equation to find my y value. So this will be the cubed root of 0 squared minus 2 squared. And that'll end up being 4, cubed root of 4. So that'll be the cubed root of 4. So my order pair would be 0 and then the cubed root of 4. And then the second part of the question wants to find out and for which value the derivative does not exist. Well, the derivative does not exist is when the derivative is undefined. So that means I'm going to look at this, and to find the derivative does not exist, this would have to equal 0. That would make that undefined. And so I'm going to take 3 times the x squared minus 2 raised to 1/3 power is equal to 0. Divide both sides by 3, and that's still 0. Raise both sides to the 3rd power. I know it's still 0. So I'm going to have x squared is equal to 2. So x is equal to plus or minus the square root of 2. It wants the points. So the x value is going to be the positive square root of 2 and a negative square root of 2. And the y values, when you substitute back in, should be 0 because that's what you said equal to. Oh no, I lied to you. I'm going to put 0 in here. I'm going to put the square root of 2 in there. Oh yeah. So this will be the cubed root of 0 minus 2 squared. But we just, oh no, square root of 2 squared. Oh, I did that all wrong. Let's try not skipping stuff, shall we? Here we go. Rewind. F of the square root of 2. F of the square root of 2 would equal the cubed root of the square root of 2 squared minus 2, this whole thing squared. Well, the square root of 2 is 2. 2 minus 2 is 0. 0 squared is 0. 0. So this will be 0. And it doesn't matter if I made this negative. When I square it, it's still going to be a positive 2. It's still going to equal 0. So this also is going to be negative 2. Negative square root of 2, 0. Okay, differentiation quotients when you have a constant. So remember, we learned how to rewrite this. So if I were going to rewrite this, if I want a quick, easy way to find the derivative of this, I'm actually going to think of this as f of x. I'm going to think of this as a 5 outside. And I'm going to think of this times the quantity of 2x minus 3 raised to the negative 2 power. Since I have a constant here, I don't have to bother doing the quotient rule. I can just rewrite this power to the negative power. Only do it when it's constant up here. So now I'm going to do the derivative. So I'm going to take negative 2. Well, here, I'll just leave the 5 out here and show you what I'm doing. To take the derivative of this, I'm going to take negative 2. Leave this alone. And then reduce this by 1, so this will be now raised to negative 3 power. And then doing the chain rule, look inside and take the derivative of what's inside, and that's just going to be 2. So I'm going to have 5 times negative 2 times negative 2, which is going to be negative 20. And then this, I'm going to write in the denominator is 2x minus 3, that whole thing raised to the third power. And that's my derivative. That's a much easier way of doing it than doing the quotient rule. You could still do the quotient rule if you wanted to, but why? Number 6, you're simplifying by factoring out the least powers. So that has to do with how we clean it up at the end, I guess is the best way. So notice I'm taking this times this, which means I'm going to have to use the product rule along with this part is going to involve the chain rule. So I have a lot going on here. So when I take the derivative, remember, I leave the first function alone. Then I take the derivative of this, which will be, this is understood to be raised to 1/2 power, so times 1/2, the quantity 2 minus x squared. Reduce 1/2 by 1, so that would be negative 1/2. And then multiply the derivative of what's inside here. The derivative of 2 is 0. The derivative of this x squared would be 2x, but because of that negative sign will be negative 2x. Plus, because I'm using the product rule, now I'm going to take the derivative of the first term, so this will be 3x squared, and then leave this one alone, so this will be 2 minus x squared, and that's raised to the 1/2 power. Before I do anything, I'm going to combine, well, put all these together. So 1/2 times 2 would be 1, then negative times, so that would be negative x to the 4th. Negative x to the 4th times 2 minus x squared to negative 1/2 plus 3x squared times 2 minus x squared to the positive 1/2. Now, when I'm doing this, I can see very easily that I can factor out an x squared, because that would be my least common factor for those two, my greatest common factor between those two. What I also need to notice is when I look at these parentheses, this 2 minus x and 2 minus x are the same parentheses, they're the same factor. One's raised to the negative 1/2 power, the other one's raised to the positive 1/2 power. I'm going to factor out the lowest power. So the lowest power between a negative 1/2 and a positive 1/2 is going to be a negative 1/2. So I'm going to factor out that 2 minus x squared to the negative 1/2 power while I'm factoring out those x's. So let's see what that looks like. So new color here. Here we go. All right, so I decided to factor out an x squared. So I will do that. So x squared. I'm just going to factor out a positive. I'm not going to bother with a negative. And I'm going to factor out this 2 minus x squared to the lowest power, which is negative 1/2. Then I'm going to put a nice big bracket because it kind of tells my mind to pay attention. Then I ask myself, what do I have to multiply x squared by to get a negative x to the 4th? And I say negative x squared. This 2 minus x squared to negative 1/2 power is exactly what I have here, so I don't have to put anything there. I could put a times 1 there if I wanted to hold the place. Good habit to get into, especially if there's nothing else there. So I'm going to write that plus 1. Here's that plus sign right there. What do I have to multiply x squared by to get 3x squared? And you say 3. And then what do I have to multiply 2 minus x squared to negative 1/2 power to get 2 minus x squared to the positive 1/2 power? Remember, when you're multiplying two numbers with the same base, you're adding exponents. So over here on a little side note, for those of us who don't like fractions, this is negative 1/2. What do I have to add to that negative 1/2 to get a positive 1/2? That's what you're asking yourself, because this has an exponent of negative 1/2. I need to get back to this exponent of 1/2. Add 1/2 to both sides, and you see that a is equal to 1, which means that this will just be 2 minus x squared to the first power. Now, still in the mode of cleaning things up here, because I would say this ends my calc level. The rest here is all algebra, and algebra is important. So let's get to it. So here, this x squared is going to stay up here in the numerator. And then, since this is being raised to the negative 1/2 power, I'm going to bring that down to the denominator, 2 minus x squared to 1/2. Here, if I distribute my 3, I'm going to have 6 minus 3x squared. When I combine my like terms, I'm going to have negative 4x squared plus 6. And this whole thing right here is my derivative. Okay, that wasn't too bad. Let's try another one. Okay, this one I'm taking a derivative of a quotient. I'm going to have to use a quotient rule to do this. So we will follow the pattern for taking the derivative of a quotient. And then in order to take the derivative of this denominator, I am going to have to use the chain rule. I just want to rewrite this because I didn't rewrite the last one. I kind of felt bad about it. So I'm going to rewrite this as x squared plus 3. And since I'm taking the cube, that's understood to be the 1/3 power. All right, doing the chain rule. So chain rule says that I leave the denominator alone. So x squared plus 3, that whole thing raised to 1/2 power. Take the derivative of the numerator, which will just be 1, minus. Take the derivative of the denominator. So take the derivative of the denominator using the chain rule. I have that 1/3. Whatever's in the parentheses stays the same. Reduce this by 1, so that'll be negative 2/3. Multiply it by the derivative of what's in here. So that's going to be 2x. And then the last thing I do is multiply by the derivative of the numerator, which is just 1. And this is all over. Oh no, oh my bad. I leave that alone, that's x. I put this all over x squared plus 3 to the 1/3 power, but I'm squaring that. Okie dokie. So here, I'm going to have x squared plus 3 to the 1/2 power minus, when I multiply all this, I get negative 2x squared there's a negative sign, so 2x squared over 3, and then this is times x squared plus 3 to negative 2/3 power, and this is all over, all right, x squared plus 3, raise the power to a power, I multiply and I get 2/3. Okay, can we all agree to get rid of this 3? To get rid of this 3, it's like I'm going to multiply this whole thing by 3. I'm going to multiply both numerator and denominator by 3. So these 3's will simplify, but then I'll have 3 times x squared plus 3 to the 1/2 minus 2x squared times x squared plus 3 to the negative 2/3. And this is all over 3 times x squared plus 3 to the 2/3 power. Then I'm going to factor out what my greatest common factor in my numerator. So I'm looking at the 3 and the 2x squared. They have nothing in common. But I do notice that this parenthesis, this x squared plus 3, is the same. And one's being raised to 1/2 power, one's being raised to negative 2/3 power. I'm going to factor out the least power. So in this case, I'm going to factor out the negative 2/3. So when I do that, I'm going to factor out x squared plus 3 to the negative 2/3 power. There's my bracket to remind me that I'm multiplying. This 3 will stay here. What do I have to multiply this by? Raised to the negative 2/3 power to get the same thing raised to 1/2 power. So that's this over here. You have negative 2/3 because you add exponents. What do I add to that to get a positive 1/3? And if you do the math, you're going to get a is equal to 1. So this will be x squared plus 3 to the first minus, and then 2x squared. And then this is exactly what I factored out, so that's all I need. All over 3 times the quantity of x squared plus 3 to 2/3 power. So now I'm going to do two things at once. First of all, since this is negative, this is raised to negative power, I'm going to bring this down. So when I bring this down, it's going to be like times x squared plus 3 to 2/3 power. Remember to do that. I'm going to add the exponents. So my denominator is going to be x squared plus 3 to the 4/3 power. My numerator, this will be 3x squared plus 9, and then minus 2x squared. So this will end up being x squared plus 9 in my numerator. And that is my derivative. Make sure that you've simplified what you can simplify. You have no negative exponents. Okay, simplify the derivative. So this one, I have a lot going on. I'm raising the whole thing to the second power, so I'm going to have to do the general power rule first. Then I have the quotient rule, so I'm going to have to do the quotient rule for the function. And then when I take the derivative of the denominator, I'm going to have to do the chain rule for that as well. So when I start this, I'm going to take care of this 2 first. So to take care of that 2, raising something to the second power, the derivative would be 2 times whatever that is, so 3x minus 1 over x squared plus 3. Don't change that at all. Raised to the first power. That's taking care of this being raised to the second power. Now I'm going to multiply that by taking the derivative of this fraction, which says that I leave the denominator alone. Take the derivative of the numerator, which is 3, minus take the derivative of this, which would be 2x. Leave this alone, 3x minus 1. And this is all over my denominator squared. So then when I do this, I'm going to just, can't. So on my numerator, this 2 is on my numerator, so I'm going to have two times, so I'm going to have 2 times 3x minus 1 times, and then I'm going to clean this up here, switching colors real quick. Can I switch colors? I don't know if I can. I sure should. Here we go. So this will be 3x squared plus 9, and then this is minus 6x squared plus 2x. So I'm going to combine my like terms, and I'm going to get negative 3x squared plus 2x plus 9. I believe that's mine. And then this is going to be all over my denominator, which I have x squared plus 3 to the second power, but I'm multiplying it by this to the first power. So this will be x squared plus 3 to the third power. And that's my derivative. I don't think I can do anything else with it. So this one, I'm going to take the derivative using the power rule. I just wanted to put this one in here because, yeah, but this looks really complicated, but it's really not. It's probably the easiest one we've done in the last couple of problems. I'm going to rewrite it before I start, though. And I'm going to make this 5x to the fourth plus 1. That's raised to the 1/3 power minus 1. And this whole thing is raised to the 1/4 power. So this is just strictly using the chain rule. So I'm starting from the outermost function, which is that 1/4 power, and working my way in to get to that x. So to take the derivative, I'm going to take 1/4 times 5x to the fourth plus 1 to 1/3 minus 1. reduce this by 1, so this will be negative 3/4 power, times. So that took care of the 1/4. Now I'm going to take care of the derivative of this, which means I'm going to take care of the derivative of that 1/3. So this will be 1/3, and then it's 5x to the 4th plus 1, subtract that by 1, so negative 2/3. And then the derivative of this 1 is just 0. So I could write plus 0 if you wanted to. I don't have to. Yeah, maybe I will. All right, plus 0. So that's that. And then the next thing I have to do to take the derivative, I have to take the derivative of what's inside here. So the derivative of what's inside here is going to be, this will be times 20x to the 3rd. So this should be like, there should be a parenthesis around it. Okay, so this, when I think of this, I have to think of like numerators and denominators. So here I go. That 4 goes in the denominator because it's 1/4. I could put a 1 up there if I want to. This, since it's raised to negative 3/4 power, I'm going to put that in the denominator. Parentheses are important. You have to have parentheses around this and around this whole thing. They have to be separate. This 3 will go in the denominator. Here, I probably should switch colors so I can see what I'm doing. So this is times the 3 will go in the denominator. This will go in the denominator. This 5x to the 4th plus 1. And that's being raised to 2/3 power. And then that would be the 1 for the 1/3. And then this 20x to the 3rd, that 20x would be in the numerator. So now when I think of this, I'm going to have my derivative is going to be 20x to the 3rd all over the 4 times the 3 is 12. And then I'm going to have 5x to the 4th plus 1 to 1/3 minus 1. This whole thing's raised to the 34th times. And then 5x to the 4th plus 1 to the 2/3. And the only thing I think I have left to do is I can simplify this 20 and this 12. They're both factorable by 4. So this would be 5 and this would be 3. And that would be my final answer. Of course, I should take the time to rewrite it, but you get the gist. Okay. Trig functions. All it's saying is if you're taking the derivative of a sine and you have a function inside, we've done one like this before, you're just going to take the derivative of sine. Well, the derivative of sine is cosine, so this derivative would be cosine. Leave that 2x alone, and then you take the derivative of what's ever inside, or my u, in this case, the derivative of 2x would just be 2. So my final answer is going to be 2 cosine 2x. And that's all you have to do for a trig function. It follows the same patterns. You still have to know those for your different trig functions. They're not changing. They're just adding the derivative of u on the outside. Everything else stays the same. All example 11 showing you is you have to be careful of parentheses. So if I have this cosine 3x squared, know that the 3x squared is written like this. That's different than if it's written like this. Do you see how they're different? So you have to pay attention to where where the square symbol goes. So this just means that the x is squared. This squared out here means the whole 3x is squared. If the squared symbol goes here, and I were to write this as cosine 3x, and I had the squared here, that would mean that I would take the cosine 3x first and then square the whole thing. So because of the chain rule, it matters where that exponent is written, because the outermost one gets the derivative first, and then you sort of work your way in towards that x. So here's one where I have a lot going on. I have 3 things going on to this variable t. I have it multiplied by 5, I have taking the cosine of it, and I have raising it to the cube power. So if I were to substitute a t in there, like pi, I would take 5 times pi first. Then I would find the cosine of 5 pi. And then once I found the cosine of 5 pi, I would raise that whole thing to the 3rd power. When you're doing the chain rule, it's kind of like you go opposite of that order. So I'm going to rewrite this So everyone understands that if this is a cosine of 5t, this whole thing is being raised to the third power. So to do the chain rule, I'm going to start with this raising to the third power first. This is going to be my first one that I'm going to consider as the third. So to take the derivative, that's going to be 3. Leave this exactly the way it is, cosine 5t. And now I'm going to reduce that by 1, which will be 2. Then I'm going to look at the cosine part. So I'm looking at the cosine, and the derivative of cosine is negative sine. So I'm going to multiply this by a negative sine, leaving that 5t alone. And the last thing I'm going to do is look at that 5t. And I'm going to take the derivative of 5t, which will just be 5. I'm going to multiply all these together and kind of clean it up a little bit. So I am going to have the 3 times the negative times the 5 will be negative 15 cosine 5t. This whole thing is squared, so I can put the squared sign there, or I can wrap the whole thing in parentheses, times the sine of 5t. And just so we're clear, I like the parentheses around the 5t because that way I know I'm taking the cosine of 5 and t, 5 times t, not taking the cosine of 5 and then multiplying by t. So that's my little pet peeve for the day, so now you know. Okay, not doing these two. And then find the tangent line of the trig function. So what I'm going to do is I'm going to find the derivative of this 2 tangent cubed x at that point. So before I start that, I'm going to rewrite it as 2 tangent x, and then this is taking the second power. Then what I'm going to do is I am going to use the chain rule. So I'm going to take 2. Oh, this is raised to the third power. So I'm going to take 3 times 2, which is 6. Then this will be tangent of x. Reduce this by 1 to the second power. Then I'm going to take the derivative of tangent. The derivative of tangent x is secant squared x. So now now I'm going to find the derivative at pi over 4. So this will be 6 times the tangent of pi over 4, and whatever I get for that, I'm squaring it, times the secant of pi over 4. Whatever I get for that, I'm squaring that as well. So knowing my unit circle, the way I know my unit circle, the tangent of pi over 4, that's easy, that's 1. So this will be 6 times 1 squared. Secant you might not know, but secant is the reciprocal of cosine. The cosine of pi over 4 is the square root of 2 over 2. The secant is going to be the reciprocal of that. So 2 over the square root of 2. When you simplify that, you get the square root of 2. So this will be times the square root of 2 squared. So that'll be 6 times 2, which is 12. So that means the slope of my line is 12. So this is my slope. We all know that. So now I have the ordered pair of pi over 4, 2, point slope person. So I'm going to say y minus 2 is equal to my slope, which is 12, times x minus pi over 4. So when I distribute that 12, I get 12x minus 3 pi. Add the 2 over, so y is equal to 12x minus 3 pi plus 2. And that's the equation of my tangent line. I hope this helps, and I will see you when I see you.